Hello, we are going to learn today about multivariate calculus. Not going to get into too much calculus today, just multivariate portion of it more. So today's notes are going to come from your textbook, Chapter 11, Section 2, titled Space Coordinates and Vectors in Space. Okay, so let's start with our first example, number 1, which the directions say plot the points in the same 3D coordinate system. Okay, so we have 2 points to plot. Point A is going to be at 3, -2, 5, and point B at 4, 0, 5. So, what does this mean? We will need to create a 3D coordinate system on a 2D surface, which is a piece of paper, which is a little tricky. So the way we normally do this is we only plot the positive axes when we're trying to get started, just so it doesn't get too overwhelming and confusing. So let's think about the first quadrant. We have up and we have sideways. Normally this would be X and Y, but for 3D purposes we're going to have Y be here, Z be going up, and X, the X-axis, is going to come out like it's coming off the page towards you, okay? So now we're in 3D. It's kind of like I've drawn one corner of a cube here or something, of a box. So this is X, Y, Z. So I'm going to go ahead and mark off little 1, 2, 3, 4, 5. What's my biggest number? 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so if A is at 3 for X, I'm going to go over 1, 2, 3, and then it is -2 for Y. So that means instead of going to the right 2, I'm going to the left 2, so back here. Now you can kind of think of this as like drawing a little parallelogram. So we're basically right here right now, -2 for our Y and +3 for our X. So this is parallel to here and this is parallel to here. And then we have to go for Z up 5. The thing about it is we don't actually go all the way up to where that 5 mark is. That would be up too high. We want our line to be like coming parallel just above this point at the same angle that this is. So we could go over to like above this one and then out till we're 1, 2, 3 like this. So then right about here would be where my point A falls. So it's kind of like if you imagine making a rectangular prism with keeping your sides parallel. That's how you get your point plotted. Let's see, I could use a pencil to kind of sketch it out. So here's 2, here's 2, be like 2 here, here's 3, here's 3, here's 3, here's 3, here's 5 up, here's 5 up, here's 5 up, and here's 5 up. So there's, I don't know, can you see that? Don't have a very dark pencil here for the video. So there we go. That's kind of like how you build your point out here at point A. Now, point B is a little easier because we got a 0 in here. So we have 4 for X. So I'm coming out 1, 2, 3, 4, one more than we were before. And 5 for z, we got 0 for y, so we're not going sideways. So we're just going to go straight up from where we are here, 4, up 5 units. So it's like if this was 5 and we come back out 1, 2, 3, 4, a little further out here, right about here would be where my point B is. Trying to make the line for the x-axis parallel to the, for the 4. I went kind of up 5. If these were parallel, it might need to be a little lower. There we go. Sorry. I came out from the 5. I needed to come out from the 4. So here's B. All right. Now, are we artists in math class? Sometimes we need a few little art skills, but we are not artists, so it doesn't have to be perfect, but just do the best you can. And that will be good enough. So have fun with that. Okay, number 2. I forgot to kind of introduce the idea of multivariate calculus. So multivariate calculus basically just means that you're still learning how to do the exact same things you did in Calculus 1 and Calculus 2, like derivatives, limits, integrals, series, polar parametric vector kind of calculus. This is going to get into some vectors today, but we're doing it with at least 3 dimensions, so x, y, z plane. So multivariate calculus is not really doing any math that's any harder than what you did in Cal 1 and Cal 2. It's basically just doing it with more variables. So the problems are a little bit more lengthy, maybe a little bit more involved. Definitely more attention to detail is helpful, but the overall level of difficulty of the problems are the same. So here we are going to find the distance between the points, which is great. We're going to do the distance formula. We know the distance formula from, we started that probably in geometry, maybe even algebra. So x2 minus x1 squared plus y2 minus y1 squared, but it is extended a little bit because we have z's now, plus z2 minus z1 squared. So there's how you find the distance in the 3-dimensional coordinate system. So 2, -3, 5, and 6, 7, 11 are what we're going to find the distance between. So we just substitute these values into the formula. Here's my x1, y1, z1, x2, y2, z2. So we start with our x2, which is 6, minus our x1, which is 2, parentheses squared, plus 7 minus -3, parentheses squared, plus 11 minus 5, close the parentheses squared. So the distance would equal 4 squared plus 10 squared plus 6 squared. So the distance would equal the square root of 16 plus 100 plus 36. So the distance is equal to 152 under the square root. And that is not a square number, but it does have a square factor. 4 goes into 152. So we can pull the 4 out. 2 on the square root of, that would leave 38. 4 times 38. Yeah. So that's the answer. There we go. Okay, so we did distance. Now for number 3, we're going to find the midpoint. Find the midpoint of the line segment joining the points. So the midpoint would be x1 plus x2 divided by 2, y1 plus y2 divided by 2, and z1 plus z2 divided by 2. So pretty close to the midpoint formula you've worked with previously. So our points are 4, 0, negative 6, and 8, 8, 20. So we just substitute these values into the formula. 4 plus 8 divided by 2, 0 plus 8 divided by 2, negative 6 plus 20 divided by 2. So 12 divided by 2 is 6, 8 divided by 2 is 4, 14 divided by 2 is 7. There's the midpoint, whoops, of the line segment joining those two given points. All right, that was example 3. Moving on to example 4. Okay. Find the standard equation of the sphere. So here we go. X minus x sub 0 squared plus y minus y sub 0 squared plus z minus z sub 0 squared equals r squared. It looks very much like the formula for a circle, except for since we're in 3D, this is not going to be a circle, this is going to make a sphere. The center of the sphere will have coordinates x naught, y naught, z naught. Why not? And the radius is equal to r. All right, so that's the information you need to know to solve the problem. And then they're going to tell you here, try to make a equation in standard form for a sphere whose center is at the point 2, 0, negative 4, and whose radius is equal to the square root of 3. Beautiful number. So we substitute the center in for x naught, y naught, z naught, and the square root of 3 will substitute in place of the r. So it's going to look like this. X minus 2 quantity squared plus y minus 0 quantity squared plus z minus negative 4 quantity squared equals the square root of 3 squared. And now we simplify. So we'll have x minus 2 quantity squared plus y squared plus z plus 4 quantity squared equals 3. And that is the answer. Okay. Number 5, our last example. Complete the square. Woohoo! To write the equation of the sphere in standard form, find the center and radius. Okay, so here's what you'd be given. 4x squared plus 4y squared plus 4z squared minus 24x minus 4y plus 8z minus 23 equals 0. So I know you just glanced at that and said, hey, I know that's an equation of a sphere. Maybe. Okay, so how do we complete the square? We've slept a few times since we've completed the square, but we've done that earlier this year. We're going to group the terms that have the same variable. So I'm going to put my x's first, then my y's, then my z's. So 4x squared will go with negative 24x, and then I'm going to leave a space. And then I'm going to put my 4y squared and my negative 4y together and leave a space. and then plus 4z squared plus 8z and leave a space. And then I'm going to take that negative 23 and move that constant to the opposite side by adding it to both sides so it equals 23. Now, when we complete the square, we add this very special number to both sides of the equation, which would be 1/2 of your b value, which is like your linear term, squared. And obviously when you square it, if it's negative, it's going to become positive, so the sign doesn't really matter. We just basically take the coefficient of your x, your y, or your z, divide it by 2 and square it, and you're going to add that. Now, before we do that though, we need to get the coefficient of the squared variable pulled out in front. So this is going to be 4 times the quantity x squared minus 6x, I'm going to leave a space, plus 4 times y squared minus y, leave a space, plus 4 times z squared plus 2z, leave a space, equals 23. So all I did right now is factor out these 4's that are the coefficients of the squared variables. Now, the b term is the linear term, the one with no square. So 6. 1/2 of 6 is 3, squared is 9, so I'm going to add 9. But did I really add 9? No, I actually added 4 times 9, which is 36. So to keep this equation balanced, I'm going to come over here to the 23 and put plus 36. Now here, the linear term is 1, coefficient of 1. 1/2 of 1 is 1/2. 1/2 squared is 1/4, so I'm going to add 1/4. But what I really added was not 1/4, it was 4 times 1/4, which is 1. So I'm going to add 1 over here. Now over here, the linear term has a coefficient of 2. 1/2 of 2 is 1. 1 squared is 1, so I'm going to add 1 here. And 1 times 4, I actually added a 4, so I'll put plus 4 over here. Okay, so now the right side, I'm going to go ahead and add these numbers up. What is 23 plus 36 plus 1 plus 4? 64. Okay, now I'm going to have 4 on the parentheses. I'm going to rewrite this quadratic trinomial as the square of a binomial. And the way I'm going to do that is I'm going to take the square root of the first term, so the square root of x squared would be x, sine of the middle term, so that's minus, and then the square root of the constant term, so the square root of 9 is 3. Put that in parentheses and square it. This is equivalent to this. You could FOIL this out by multiplying x minus 3 times x minus 3. You'll get that. Okay, so we're going to do the same thing here. Plus 4 times square root of y squared is y, sine of the middle term is negative, square root of 1/4 is 1/2, quantity squared, plus 4 times square root of z squared is z, sine of the middle term is plus square root of the constant term is 1, close the parentheses, squared. Now, this is almost in the standard equation form that we talked about earlier, except for they didn't have coefficients in front of the squared terms. So what we need to do now is divide the whole thing by 4 on both sides. So that'll divide out all those 4's, and we'll have x minus 3 squared plus y minus 1/2 squared plus z plus 1 squared equals 64 divided by 4, which is 16. And now that's the equation in standard form. That's the first part of the answer. Then we also were supposed to identify the center and the radius. So the center is going to be 3, 1/2, -1. Remember, there's a minus in the formula, so the sign is opposite of whatever you see in the middle. And now the radius is the square root of this that the equation is equal to, because 16 is r squared. So the radius would be the square root of 16, which is 4. And that's it. So for your assignment, you're going to do Chapter 11, Section 2 on page 763, number 1, 3, 23, 25, 33 to 43 odd. We didn't do much in the way of taking derivatives or integrals or calculus, but we did 3 variable stuff. And I have been told by my former students that just introducing the 3-dimensional coordinate system and kind of getting that idea mulled around in your brain a little bit can greatly help before you go into multivariate calculus. So I hope this gives you a little bit of a leg up. And I hope you have a wonderful day, and email me if you have any questions, and I hope to see you again soon. Bye for now.